Hello everybody. In this video we're going to cover the derivation of the quadratic formula. Now the question is, what is a quadratic formula and what is it used for? Quadratic formula is a way to find the x-intercepts and y-intercepts of a quadratic equation. The reason why we need that is because sometimes it's not possible to find integer whole numbers to decompose the p-value. So let me show you that in a sec. So again, here is a success criteria question, so make sure you're able to do this question after the video lesson. Okay, so let's look at this review. We're going to solve this by factoring. So remember, to factor, we need to decompose this p-value into two numbers that add up to 3 and multiply it to 2. So the two numbers that work are 2 and 1, right? 2 plus 1 is 3, and 2 times 1 is 2. So this is what I mean by being able to decompose the p-value into whole number integers, right? So we get whole number, but sometimes it's not possible, and I'll show you an example right after this. So x squared plus decompose of 3x, 2x plus 1x plus 2, and then we group the first two and group the second two, and we factor out something common between the first two terms. Factor out, nothing's really common, so we factor out a 1, and then we can factor out x plus 2 from both terms, and then we're left with x plus 1. So the answers are negative 2 and negative 1. If you put a negative 2 for x, you get negative 2 plus 2, which is 0. 0 times any number is 0, so that works. And negative 1 works as well. So the answer is x is equal to negative 2 and negative 1. So again, these are the x-intercepts. So x-intercepts are at negative 2, which is here, negative 1, which is here, so it'll look something like this. Okay, so that was straightforward. But then let's say you have a question like this, x squared plus 4x minus 6. What are two numbers that add up to 4 and multiply to negative 6? Well, some numbers are 2 and 2, 3 and 1, 4 and 0. But none of these multiply to negative 6. So we have a problem. So what's difficult about this problem? There aren't any integer numbers that decompose, that add up to, that sum to 4 and multiply to negative 6, right? So that's the problem. So we can solve this a different way. And the reason why we're solving it this way is because I feel that this might be the easiest way to do it, and also this shows you where the concept of the quadratic formula comes from. So let's start with this. Complete the square. So remember, to complete the square, you take the first two terms and then try to make a perfect trinomial by adding and subtracting a number. And we add and subtract this b number divided by 2 squared, which is 4 divided by 2, which is 2 squared, which is 4. So we add and subtract that, and then the reason why we do that is because adding and subtracting the same number is like adding 0, so you don't change the equation. So next step is to factor the first three terms. So factoring x squared plus 4x plus 4 will give you x plus 2 squared. Right, and then we simplify the remaining, which is minus 10 is equal to 0. Okay. The next step is to isolate for x, and we're going to start that here. So we isolate for x by adding 10 on both sides first, which equals 10, square rooting both sides. And remember, there's two answers for this, because square root of 10 squared is 10, but also negative square root of 10 is 10. Okay. And then the last step is to subtract 2 on both sides. So we get plus minus root 10 minus 2. Rearranging, we can put negative 2 at the front, and then we get negative 2 plus and minus square root of 10. And there's the answer. Perfect. Okay. So as you can see, the number isn't really nice. And that's why there's no way, well, there might be a way to decompose it. Well, there might be a way to decompose it, but it'd be very hard, as you can see. So let's say the question asks you to write in a factored form. Okay. Since we know the x-intercepts, we know partially what the factored form would look like. It's going to be equal to x minus one of the factors, and then x minus the other factor. Okay. But there's a catch. You need a constant at the front of the equation. The reason why you need a constant is because, let's say the original equation, x squared plus 4x minus 6, looks like this. Okay. The factor form that we found, this part right here, it has the same x-intercepts, but it might look more like this, or like this. So that's why we have a k-value here that we put, because we're unsure what this is. And this k-value will determine whether if it looks like 1, 2, or 3. And then there's a way to solve for this k, and I'll show you that after. Okay, so before showing you that, we need to follow up and actually derive the quadratic equation, which was the main point of this video. And we're going to derive the quadratic formula by taking the same steps as what we did previously, but we use variables a, b, c instead of the actual numbers. Okay, and then once we follow the same steps using a, b, c, we'll get some answer with a, b, c in it. And then this answer with a, b, c in it will be our formula for the quadratic formula. So let's get started. Step 1, like we did before, we complete the square. We're going to complete the square for this. And remember, if our coefficient in front of the x squared is not a 1, you need to first factor out that coefficient, so we get a coefficient of 1 in front of the x squared. Okay, so that's the first step. Second, you need to add and subtract a number so that you can get a perfect trinomial. Remember, you take this number, divide by 2 and square it. So it's going to be plus b over 2a squared minus b over 2a squared plus c. Now we're going to factor the first three terms inside the brackets. X plus b over 2a squared minus b over 2a squared plus c. We're going to take this out of the brackets. A x plus b over 2a squared minus b over 2a squared times a plus c is equal to 0. Take rid of that bracket there. Okay, and then we can simplify this further by distributing the square to each of the numbers and variables inside the brackets there. So we get a b squared over 4a squared. And then we can take one more step by simplifying this fraction. Because there's an a in the numerator and the denominator, we can cancel those out. And we get b squared over 4a squared plus c. Okay. Now step 2 was to isolate for x. X is over here. So we need to subtract c, add b squared over 4a squared, divide by a, and then subtract b over 2, square root, and then subtract b over 2a. Okay. So we're going to add b squared over 4a squared and subtract c, and then divide everything by a. Oh, that's the problem. Okay, so I made a little error here. So remember, at this step we had a b squared over 4a squared, and the a should have canceled, so there should be only one a. There you go. Okay, now we're going to divide by a, both sides, which equals b squared over 4a squared minus c, and then square root both sides, square root b squared minus 4a squared minus c. Okay, and then we're just going to do a little manipulating and simplifying. So on the right side, we have b squared divided by 4a squared minus c. We are going to, no, it's 4a, right? No. Oh, sorry, I made another mistake. You need to divide c by a too. Because when you divide by a, you need to divide everything here by a. Okay. So then I'm going to make this into one fraction. Why do I have a square? Oh yeah, okay. So I'm going to make this into one fraction, so I need to multiply this by 4a over 4a. So we get the same denominator. So we get b squared minus c over 4a squared, 4a. Okay, and then we're going to subtract b over 2a on both sides. Okay. We can further simplify this by taking this square root of this fraction and square root the numerator and denominator separately. So we get square root of b squared, oh, I forgot the plus minus b squared minus 4ac all over 2a minus b over 2a. Okay. And then the next step would be to put this together, these two fractions together, because they have the same denominator. So we are left with negative b plus minus square root b squared minus 4ac all over 2a. Okay. And this is the quadratic formula. So next, we're going to use this formula and see if it works with this question. Okay, first we're going to use method 1 by factoring by decomposition, and then we're going to compare it to the answer we get by using the quadratic formula. So we need two numbers that add up to 7 and multiply to negative 18. Okay, so it seems like 9 and negative 2 work. Okay, so we're going to decompose it. Plus 9x minus 2x, so these two add up to 7x minus 3. And then, of course, we group these and these, factor out the common factor between the two, factor out negative 1. Between these two, this should be 2. And then factor out 2x plus 3 from both, and you're left with 3x minus 1. So it looks like the x-intercepts are minus 3 over 2 and 1 over 3. Right? To get these answers, all you have to do is solve for 2x plus 3 is equal to 0. So that's what you're trying to do, make it equal to 0. X is going to be equal to 3 over 2. Okay, so this is the answer we got. And then we want to see if we get the same answer after using the quadratic formula. So the quadratic formula that we got from above was negative b plus minus square root b squared minus 4ac all over 2a. Okay, and our original equation was 6x squared plus 7x minus 3. So this is the a, this is the b, and this is the c. So we sub that in to the equation, formula, negative 7 plus minus 7 squared minus 4 times 6 times negative 3 all over 2 times 6, which equals negative 7 plus minus 49 plus 24 times 3, 72 all over 12, which equals negative 7 plus minus 121, 12, which is negative 7 plus minus 11 over 12. So our answers are negative 7 plus 11, which is 4 over 12, and negative 7 minus 11, which is negative 18 over 12. And then if we simplify this, we get 1 over 3. And simplify this, we get negative 3 over 2. Okay, so yeah, the x-intercepts are the same. How about writing this in factored form? Remember, the factored form would be x minus one of the roots, and then x minus the other root. It's going to be plus because 3 over 2 is negative. Okay, So this is the part where it's not exactly the factored form that we got from above. That's because, like I just mentioned before, near the beginning of the video, that we get the same x-intercepts. The quadratic formula gives you the x-intercepts, but it doesn't give you like the exact equation from the beginning. So let's say this is 6x squared, what was it? 6x squared plus 7x minus 3. Okay. This equation that we got has the same x-intercepts. So this and this. Let's say this is negative 3 over 2 and 1/3. So it has this, but maybe it looks like this, or like this. So you need to find a k that works so that it makes it look exactly like the original. And how do you find this k? What you can do is sub in y and x for this equation and then solve for k. And make sure that the y and x, the coordinate xy that you use, is a coordinate on the original graph, okay, on the original equation. So the y and x that we can use is maybe 0 to make it easy. So if x is 0, you can see that y is negative 3. So we'll use 0 and negative 3. So y is negative 3, k 0 minus 1/3, 0 plus 3 over 2, which equals k times negative 1 over 2. So k is equal to 6, right? Since k is equal to 6, this means our equation is 6x, 6 bracket, x minus 1/3, x plus 3 over 2. Now you're still wondering why it doesn't look like this. You just need to manipulate a little bit to make it look the same. Okay, so I decomposed 6 into 3 times 2 is 6. And then what we're going to do is we're going to multiply 3 into these, and we'll get the same thing. So that's 3x minus 1 and 2x plus 3, because 2 times 3 over 2 is 3. And now you can see that it's exactly the same, okay, as our original factored form. Alright, so the main purpose of this video was to derive the quadratic formula and show you how to use the quadratic formula to find the x-intercepts, okay? And also use the quadratic formula to factor, to find the factored form. So that's the end of this video. If you have any questions, please email me. Okay, great job. See you next week. Bye.